All right, this is lab number 2 in ERT405. Let's take a quick run through the actual lab document, and then we will start into the programming portion. So we are going to have a student complete the logic for a simple machine and get introduced to modes and faults. So that is our purpose today. That's what our machine looks like right there. So basically 2 pushers that are going to work together. So we need to sequence them together a little bit. And we're going to have several different modes that we're going to switch between. And we're going to generate some faults as well. So our procedure for this one, in this one we'll be showing how to actually map inputs and outputs into our standard logic. So many companies have made it part of their software standard to have the real inputs and outputs separate from the motion routines, so that there are less things to change in the motion routines. So we want to use our standard logic in the motion routines and just have things connect to that. So they typically have map inputs and map output routines. Notice the scan order. Input mapping is done in the beginning and output mapping is done last. This is not by mistake. If you want to learn more about this, here is a great article. You can go to this link right here to see that. So here you can see the input and output mapping routines. And in the mapping routines file, you're going to see lots of add logic bits. So this is our add logic bit. We did this in the first lab, or a similar bit. That basically is a placeholder indicating that this is where you need to put something in place of that. So wherever you see that tag, you need to change that to a real world input or output. So that means an aliased tag from the factory I/O simulation. You will also need to create the logic for pusher number 2. So pusher number 1 is done for you. So we will be doing a copy and then search and replace for pusher number 2, much like we did in lab number 1. And then we will be testing manual mode. So we have push buttons for all of our manual functions. And then part 4, we'll be testing the faults. So this is a listing of all the faults that we will generate and how we will generate them and see them actually work. And then we will actually be running the machine in auto mode as well, and we'll need to figure out what makes this run in auto, and we'll be putting some logic in here for that as well. Alright, so there's basically 5 parts to complete. So let's see all of that going. So we have our factory I/O. I'm just going to get this opened up here. So we need our factory I/O file and our PLC file. I have the PLC file. I'm just going to grab the factory I/O. I'll get that started as well. So you'll see this is our machine. And we have our panel over here. The panel this week has a lot of stuff on it. So a lot of stuff there. This is pretty true to what a real panel would look like for a machine such as this. The one we did last week did not have a lot of the content on the panel that we would want to normally have. making sure we're good to go here. So let's have a look through this logic that we've been given and see what we have. So we have all of these routines over here. So map inputs, that is our first routine. And this basically has a bunch of add logic bits that are basically connecting to, we have an input that we're going to insert in here, and that is going to connect up directly to an output. And you can see this output is modes dot cycle start PB, so that is definitely a UDT. If I hover over that, you can see that is a tag data type is UDT.modes. So we can actually see here, if we go over under assets and user defined tags, there are 3 different UDTs that have been created in this program. So we have the advanced return. If we look at that one, this is going to be very similar to the one that we created ourselves last week. So it is now created for you. You will notice that there is an extra tag in here at the end called both procs fault. That is one extra piece that's been added to this. There is now a UDT that is called modes. We'll be using that one in the lab today. So this covers our auto, manual, auto cycle, cycle start push button, cycle stop push button, auto cycle, cycle start timer, and all of these things associated there. We have another one that is called a motor, which looks like it has clear, auto condition, and move command. That's part of the motor UDT. So all those things have been set up for us. So this first file here, mapping the inputs, we have the real I/O that's associated with pusher number 1. That would be the advance and return push buttons and the advance and return proximity switches. Pusher number 2 has the same things. Let's look at the map outputs. What do we have there? We have a bunch of lights that are done here. These look like they're already mapped for us. So auto mode turns on the auto mode light. Manual mode turns on the manual light. These have already been mapped for us. The pusher 1, advance out, return out, and advance complete, return complete. These are need to be filled in, so we need to figure out what those are going to be. And now let's go to the mode logic. So this is all pre-written for you. And you'll see this is all done with the UDTs. This is going to be what we're going to call for now our standard mode logic. So we have the auto and manual switches are going to turn on. Look at this. The auto and manual switches are going to turn on our auto mode. If we don't have auto mode, we are in manual mode. If we have auto and we are not faulted, that is auto cycle start clear condition. If we are clear to start auto cycle and we are in auto and we push the auto cycle start button, we're going to actually have to hold that down for 3 seconds. So once that timer has completed, we will then get auto cycle and we will lock that in with a seal. We will seal it until we actually hit the auto cycle stop button. That's what's going on there. And then here we have some interesting bits going on here. This is actually a flasher circuit. So this is setting up a automatic flasher. There are a couple different ways you can make something flash. This is one way to do it. So these little chunks of logic here, this is actually going to create a flashing bit. You'll see this running when we actually run, but this basically makes a blinking bit that flashes half a second on and half a second off, I believe. So we can use this to make the horn go on and off. That is its purpose right here. And then we are going to sound the horn whenever we have a fault. So it looks like whenever we have a fault, for the first 2 seconds we get that fault, we will sound the horn in a beep, 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 and then it will stop itself. That's what's going to happen there. So that is our mode logic. The pusher logic, this should look familiar to it because it's basically the standard logic we did last week. We have an add logic here bit, an add logic here. So this is our collision conditions, which we'll have to figure out. This is our starting condition for auto cycle. Everything else is basically the same of what we're going to run. Notice that here we don't have a branch around here to drive our output, our physical output anymore. We actually just are going to use this bit in our mapped outputs, and these bits here are now pusher 1 advanced procs and pusher 1 return procs. These are also mapped inputs now. Everything else is pretty much the same. The other one exception that we have is we have an extra fault at the bottom of this. We are saying create a fault called the both procs fault, which will happen if you actually get both proximity switches, the advance and return switch, on at the same time. That is a condition that should not happen unless you actually get a switch failure. So if a switch was to fail in the on position, you would get this fault coming on. Our conveyor logic is here. So conveyor logic clear to run. Nothing conditional on that one, that's just on all the time. And then we're saying if your pushers are, pusher 1 is returned, you're okay to run. This will actually stop the conveyor whenever that pusher moves. And then this is our command to run it. It will run automatically in auto mode. If we were in manual mode, you will require the jog button to be pressed in order to run, and that triggers our 3 conveyors. We have some part control logic. This is very similar to the part detecting logic that we used in lab number 1, except this one uses seals instead of latches. And this one here, this is our fault logic. This is our fault reset button, so you need to actually hold the fault reset button for half a second for the fault reset to happen. And then this here is all of our faults, so we are mapping all of our individual faults that we're using in our logic to individual fault bits. So you'll see these bits, which are called out in our file. We have a table here which calls out all the faults and describes what they do. So we can reference that if we need. But this tag called fault is actually a dint. So this is a tag that has 32 individual elements to it because it's a dint. So if we say fault.6, that is actually, I will look at the tag list here. You can see that we have a double integer tag called faults. And then if we expand this, you'll see that there's actually 32 bools that make up that integer, that double integer. So each of these individual bits that make this up, so 0 through 31, we can actually use each of these individually and turn them on or off individually. And that is what we are doing here with this logic. So we are controlling each of these individual bits. And if we examine this entire dint as a whole, we are basically checking to see, are any of these individual bits on? And the easy way to check that is to look at that entire word as a whole, which we are doing here, and we are saying if this is not equal to 0, then we have a fault, which would mean if any of these bits are on, then this will have a non-zero value. So you'll actually see this in action when we run this. So let's go through this logic and start filling in what we need to make this run. So I'm going to condense this down a little bit. I'm going to start by downloading. Actually, before I download, I need to create pusher 2. So I will do that offline because I can do the search and replacing. So I am actually going to copy and paste this entire file. So you can see how that created pusher number 2. And I'm going to rename this. So that actually did a copy and paste of the entire routine right there, including all the logic that is inside of it. So I now have this this entire set of logic right here, and I need to change pusher 1 to pusher 2. And I need to make sure that I'm moving in the downward direction. Current routine, the wrap is off. I will do a copy and paste of this, or sorry, a search and replace. And that will come up like this. For occurrences, and then I'm going to edit the properties of this as well. I'm going to put a comment on here that says pusher 2 so that I get some nice pusher 2 comments on there. I change this run comment as well so it says pusher 2. I'm going to make sure my pusher 1 logic, I'm going to make that same change over here too. I'm going to put that comment in here, make sure that says pusher 1, so I can definitely tell the difference between those. And now let's move on. The rest of this I'm actually going to do online. I like doing things online because I can actually check it as I work, even though it is a little bit slower to do the online changes, but I can verify it as I go. And you can see what's happening as I do it. So we're going to map the inputs and outputs. I've already completed the pusher 2 logic here. And we are back online. Back in remote run. I will close this. And let's go to our map inputs. So, cycle start button. I'm going to guess that this is called cycle start PB. Cycle stop button. Cycle stop PB. Fault reset push button. Fault reset PB. Pusher 1 advance push button. Pusher 1 advance push button. Pusher 1 return push button. Pusher 1 return push button. Pusher 1 advance procs. And pusher 1 return procs. Pusher 2. Forget what these were called. Advanced PB. Pusher 2 return PB. Pusher 2 advanced procs and pusher 2 return procs. Alright, so I think I have all those taken care of. Let's do some testing. Oh, I see it. A warning here. Pusher 2. Routine cannot be reached by the main routine. That message there means I added a routine, and what did I not do? I did not put in a JSR for it. If we go here, notice no green bars out here. This routine not being scanned right now because I added the routine and I did not create a JSR for it. Very common mistake, which I just made right there. So let's add in another JSR, pusher 2. We will do that. Now if we look at pusher 2, now we have the green bar out here, so that's good. Alright, so let's actually look at some logic. Let's connect this up. and try running it. Let's look at our inputs here. Cycle start PB. That should be this one. I should be getting that on. Cycle stop PB. That's good. Fault reset. I'm basically doing an I/O check right now. Let's look at the pusher advance push button. Pusher 1 advance. Pusher 1 return. The proxies I'll check in a second. Pusher 2 advance. Pusher 2 return. Alright, so I got all those correct. Let's check the switches. So I can actually do that by docking all the tags. Pusher 1 advance prox. I'm actually going to force this on. That's pusher 2 advance prox. I'm forcing that on right now. And then I'm going to remove the force from it. Make sure I don't leave any of these forced. Pusher 2 return prox. I'm actually going to force this one off. There we go. Let's do the same thing for pusher 1. Pusher 1 advance prox. And release. Pusher 1 return prox. And release. Alright, so that all checks out. Let's go to mapping the outputs. See what we have here. Modes, these things are pretty much all mostly done for us already. Let's look at pusher 1 advance output. So this one should be pusher 1, this would be our solenoid. Advanced solenoid. And it looks like these are set up as doubles. Yeah, you can see how they have return solenoids here. Advanced solenoid and return solenoid. So these are configured differently than the ones we had last week. They are actually dual solenoids. So it does actually have a return solenoid as well. And then the completes, this is trying to turn on the light. That's the advanced light. Pusher 1 return light. Pusher 1, pusher 2. Advanced sol. Pusher 2. Return sol. Pusher 2, return light. And there we go. Let's try checking these out. you know what, with these we'll actually check them when we run. Alright, so alright, we'll verify those when we actually run. So let's go to manual mode. We'll verify manual mode. Next, so let's try checking out our conveyor. So our mode logic is here. I'm going to get rid of this. Clear all the tags. There you can see this flashing logic working right now. See how that bit flashes on and off continuously. Let's try our mode logic. So right now we are in auto mode. That should put us in manual mode, and you can see the lights changing. That's manual. That's auto. So right now we are in manual mode. We should be able to move things in manual right now. For the conveyor, conveyor is clear to run. The only thing we're missing is the jog push button to run the conveyors. Let's see if we can do that. Jog push button is right here. So the conveyors all run when we do that, and we get the jog light coming on. So that all checks out. Let's see if we can move pusher number 1. Pusher 1, if we look here, notice that we are currently clear to move. We haven't addressed this yet, but we'll get to that in a minute. Right now, in manual mode, we've got the clear, we're in manual mode. The only thing we're waiting on is the advanced push button. And if we get that, we should move. So this is pusher 1 advanced. The light is showing that we are returned right now. If we push this, it should move. And you can see once it actually gets there, the yellow light comes on. That button makes us return. So we have manual control over that, and the 2 lights are indicating properly. Let's see if we have manual control over pusher 2. Yes, we do. Manual control works, and the lights indicate properly as well. So everything appears to operate properly. Let's think about what our conditions here are for collision. Is that dangerous right there? I would say let's think about that. I think for pusher number 1, I think you could take that either way. It would potentially be dangerous if you had a box up here, because you'd basically be pushing a box into the side of this here. So if this was already extended, if pusher 2 is extended, you could push a box into the side of this. So I think you could make an argument that we should say don't allow pusher 1 to extend unless pusher 2 is returned. So because of that, I think we'd say here for pusher 1 advance, we'd say pusher 2 has to be return complete. I could buy that. As far as the return motion, I don't think there's any obstruction on the return motion, so I'm good with that. For pusher 2, there should not be anything that prevents you from advancing pusher 2. There's nothing to hit there. So we'll remove that one. And the return the same way. We'll assemble those changes. So those were those add logic here bits. Now the final thing to think about is how do we actually sequence this in auto? Notice as well, with the double solenoid, we can actually bump these so they only move a little bit. They don't seal in place until they actually reach their final destination. So we have a bit under our parts logic that is called, what's this called? Push box is our final output from this. So we get that when we get a box that is gone for 0.4 seconds past here. So we take this box, place it in here, box detected, and then it moves out of there. It actually has to travel out of there, and then we get 0.4 seconds after it leaves the photo eye, we get our push box signal comes on. So at that point, that's our trigger to advance pusher 1. So this is push box. That's going to advance pusher number 1. What happens next in our sequence? So we're going to push, and that's going to end up over here. What actually needs to happen next at this point? We want to advance pusher number 2. So let's look at pusher number 2. The condition to advance this should read, we have push box, and also we have pusher 1 advance complete. So we get those two conditions, and that will make us advance here. And that causes the box to fall down here. Notice that when we do that, it actually cancels our push box signal, because that is what breaks this here. Push to advance complete is actually what breaks this. So now that we don't have push box anymore, we should be clear to return both of those motions. So the return here is going to be push box not on. That's on pusher 2, and on pusher 1 the return will happen if we do not have push box. So I think that is now correct. So that was the only thing we needed to program in here in our actual motion logic, was our clear conditions and that there, the sequencer for auto. So let's now look at this. Let's put this thing into auto and see if it works. So to get it into auto, if we remember what has to happen there, it was put the selector switch into auto, clear all of our faults, remember the fault reset button has to be held down for half a second to clear the faults. And then hold down the cycle start button for 3 seconds, and that should put us into cycle start, into cycle. All right, so there we go. So you can notice that the conveyor stops. Both our pushers advance, do their thing, and then they return at the same time. All right, so that is most of our lab complete. The only other thing we need to look at is let's test all of our faults. So we remember our fault logic. Let's check these out. So how do we trigger each individual fault? The first one is going to be our e-stop. So that one comes on when the e-stop is tripped. Let's press the e-stop. All right, that's the e-stop. And you can see how the value of this right now has a value of 1 that's not equal to 0, gives us a fault because bit 0 is on right now. I'm going to take that out. Fault reset for 3 seconds. Start the machine back up again. Pusher 1 advance fault. How do we trigger that one? Force the pusher 1 advance fault. Okay, so let's do this. let's just do this. Let's dock all the tags. We are going to disable the, so this is going to be the pusher 1 advanced procs. We're going to disable this switch so it doesn't work. So let's do that. No, I did it the wrong way. I caused a both switches are on at the same time fault. That was the third bit, which gives us a number 8, which is a different fault. This is what we want to do. We want to put that, we all want to injecting an off failure is what we want to do. We're going to do that one. I'm going to reset our faults here. So do a fault reset and then start again. And what we'll see here, see how that pushed. So we pushed, but our front limit switch never came on, which is a fault. So that is the advanced fault. I'm going to do that. We'll run again. I'm going to do the same thing. Inject the off failure on the return switch. That's this one. And you can basically follow that procedure to test all your faults. And basically following that procedure tests out all your faults there. And that is completing all of the steps from this lab. Okay, so that is the lab completed. So we learned about the different modes that we're using, the manual and auto, and the cycle start. We learned about using the mapping of the I/O, which is a very effective way to utilize the standard logic to really its full potential. It makes things very easy for cutting and pasting and being able to use some really strong templates for creating logic. We could string together quite complex machines very easily by doing this. And this very much resembles the way that a true industrial machine would essentially be programmed. So a very real-world example of a machine here. Okay, so that is the lab for this week. Good luck with it, and we'll see you later.